warahmatullahi wabarakatuh. My name is Nafisa, and I'll be presenting the introductions for our group presentation. The relationship between test scores and GPA is crucial for understanding academic success. Test scores measure specific skills in controlled settings, while GPA reflects long-term performance, consistency, and effort across courses. This connection helps evaluate whether standardized tests, such as SAT, accurately predict success, or if factors like motivation, socioeconomic background, and access to resources play a greater role. Challenges including measurement issues, such as the debated predictive power of the SAT, and internal influences like family background and financial stability. Studying this relationship is essential for assessing the fairness of standardized tests and improving admission practices and also educational policies. Moving on to the next subtopic, 1.2, objective of the study. The first one is to identify the relationship between the test scores and grade point average, GPA. Next, to develop a linear regression model. And the last one is to predict grade point average, GPA, based on a linear regression model. Next, I'm going to present to you what is the significance of this study. The first one is it helps educators identify factors influencing student success. Next, clarifies the role of standardized tests in predicting long-term academic achievement. Highlights other influential factors like motivation and socioeconomic status. And then it refines educational theories and informed teaching strategies. It also identifies true predictors of academic success for fairer admissions. And the last one, it also encourages a holistic evaluation of student potential beyond reliance on test scores. So for the last subtopic for the chapter 1, I'm going to present to you the limitations of this study. The first one is exclusion of important factors such as mental health, study habits, family supports, and extracurricular activities will affect the understanding of academic performance. Next, it requires extensive data collection over long periods to chart GPA and test scores across semester or years. Next, the advanced statistical techniques like regression analysis or machine learning also demand significant time for setup and validation. And the last one, secondary data poses challenges due to inconsistent grading skills, test formats, and limited access.
Moving on to the next chapter, Chapter 2, Methodology. First, we have data description. Data shows test composition scores and grade points average, GPA, after their first term in college. The independent variables is test scores and the dependent variables is GPA. Sample size is 21 observations. Next is graphical technique. Type of graph that can be used in this study is scatterplot. Scatterplot is two-dimensional graph that plot the individual data set. Each pair of values at x and y coordinate plotted at the diagram. Certain pattern like increasing or decreasing formed on the scatter diagram shows that there is a relationship between those two variables. We assume two variables does not have a relationship between them when the scatter diagrams does not show any pattern or randomly scattered. Third, we have numerical technique. A. Descriptive analysis. For n-group data, to find mean, we have to find sum of the given data divided by total number of data. To find median, we have 3 steps. First step is we have to arrange the data in ascending order. Next, we need to find the median location by using the formula n plus 1 divided by 2. The third step is the median value. We can locate the median value from the arranged data and determine the median value. Next, mode. The number of times the value of data that occurs the most frequent computed. B. Method of correlation. Pearson's correlation coefficient, R. And C. We have method regression analysis. We use least square method.
3.1 Data presentations. Data below shows test scores and grade point average GPAs after their first term in college. The maximum values for the test score TS is 29 and minimum value for test score TS is 15. The maximum value for grade point average GPAs is 4.000 and minimum value for grade point average GPAs is 1.833. 3.11 Scatter plot from SPSS. Scatter plot below shows the relationship between test score TS and grade point average GPAs after their first term in college. It shows that it has a moderate positive correlation between the test score and the grade point average. The linear regression equation shown in the scatter diagram below, which is y is equal to a plus bx, so that y is equal to 1.560 plus 0.077x. 3.2 Descriptive statistic analysis. The first one is mean. What is mean? Mean is the average of the data values. The formula for mean is x is equal to sum of fx over n. So based on the data, x is equal to 451 over 21 students. X is equal to 21.48. The interpretations for mean, the average test score TS is 21.48. Median. What is median? Median is the middle value of the arranged data in ascending order. The formula for median is location of X is equal to n plus 1 over 2. So, 21 plus 1 over 2 is equal to 11 positions. The interpretation for median is 50% of the data is less than 21, while another 50% is more than 21. Last one is mood. What is mood? Mood is the most frequent value that occur in dataset. Therefore, x is equal to 70. Interpretations for the mood is the mood of the test score TS is 70. 3.3 Correlation and regression analysis. Correlation. The correlation coefficient based on the formula Pearson correlation coefficients. So the formula is R is equal to sum of xy minus sum of x times sum of y divided by n over square root sum of x square minus sum of x square over n times sum of y square minus sum of y square divided by n. R is equal to 1470.89 minus 451 times 67.38 over 21 divided by square root 9997 minus 451 square over 21 times 222.64 minus 67.38 square over 21. So R is equal to 0.5325. The interpretation for Pearson correlation coefficient is there is moderate positive relationship between the test score TS and grade point average GPAs. Next is the coefficients of determination based on formula. R is equal to 0.5325. R square is equal to 0.5325 square. R square is equal to 0.2838. So R square is equal to 28.38%. Interpretation for the coefficients of determination. 28.38% of the total variation in the grade point average GPAs can be explained by the test score TS. Regression analysis, the intercept, slope, and the regression equations. First is slope, B. The formula is B is equal to sum of xy minus sum of x times sum of y divided by n over sum of x square minus sum of x square divided by n. So B is equal to 1470.89 minus 455 times 67.38 over 21 divided by 9997 minus 451 square over 21. So B is equal to 0.0768. The interpretation for slope B. Every one test score TS increase, the grade point average GPAs will be increased by 0.0768%. Intercept A. Next is intercept A. The formula is A is equal to sum of y over n minus b times sum of x over n. So A is equal to 67.38 over 21 minus 0.0768 times 451 over 21. So A is equal to 1.5592. Interpretation for intercept A. When test score TS is equal to 0, the grade point average GPAs will be 1.5592%. Lastly is regression equations. Y is equal to A plus BX. So, based on the data, Y is equal to 1.560 plus 0.077. Next is output from SPSS. Summary table. Based on the output from SPSS below, it shows that it has a Pearson correlation which is 0.533, where it means the moderate positive relationship between test score TS and grade point average G.
Thank you, Alisha, for your explanation. My name is Fatima Azahara, and now I will start with the output from SPSS, ANOVA, and coefficient table. Based on the output from SPSS, ANOVA table indicates the significant for model fit p-value of our data is 0.013. This shows that our data reach a significant model fit as the p-value should have a value is less and equal to 0.05. This means that there is a statistical difference between the temperature and percentage of yield. As the coefficient table, the constant unstandardized shows the value of the intercept, which is 1.560, and the test score shows the value of slope, which is 0.077. Furthermore, we can predict the dependent variable based on the regression model obtained by running 3 experiment data and explaining the results. If the test score is 19, we will get the percentage of 3.02. When the test score is 23, we will get the percentage of 3.33, and when the test score is 25, we will get the percentage of 3.49%. Moreover, let me show you the conclusion that we have concluded from this case study. In conclusion, the objective of this study is the relationship between test score, TS, and grade point average, GPAs, and there is a moderate positive correlation between the relationship of these variables, with an average correlation of 0.533 that can be found in this study. Other than that, most of the students hit a 3.0 GPA than the one who has a below 3.0 GPA. Moreover, the use of Pearson's product moment correlation coefficient are strengthen the relationship between the test score and the grade point average GPA. In this study, the R value is 0.53, which indicates a moderate positive correlation between test score TS and grade point average GPS. Hence, a moderate positive correlation suggests that test scores are a good predictor of GPA, but they do not account for all variation of GPA, grade point average, as there may be other factors affecting such as group project. Furthermore, based on the regression equation y equal to a plus bx, and for the value of intercept A is 15.60 and intercept B 0.077, in figure 5 shows that ANOVA and coefficient table p-value of our data is 0.013. Lastly, the dependent variable can be predicted based on the regression model obtained. Lastly is the recommendation for future work. To improve the reliability and validity in future studies, a few actions are suggested to overcome the limitation of these studies. Firstly, include the additional factors such as mental health, study habits, family supports, and participation in extracurricular activities. This can affect academic performance and provide more comprehensive understanding of student success. For instance, research by Yue Deng from 2002 proved that depression is caused by academic and family stress, which negatively impact academic performance and learning outcome. Other than that, this limitation can also be overcome by utilizing technology to automate the gathering of data over time. For example, we can implement digital tools that are able to reduce the time and efforts required for the studies, which make it easier to track elements in the study, which is GPA and test scores. But it is essential to remember we must keep being aware of challenges such as attrition or data harmonizations, as discussed by Edward Joseph Caruana from 2005. Lastly, ensuring the secondary is accurate, up-to-date, and includes all the necessary data is vital to maintain the validity of the study.